Welcome to another video on my Raspberry Pi 1 running Raspbian Linux, latest version, connected to serial interface for checking boot and other stuff, connected to Raspberry Pi camera for alternative view, also connected to a network cable for VNC, also connected to two probes to the serial port, because that is the main focus of this video, and last but not least connected to a band cable which is connected to this breadboard, and focus is now on the MCP 3008 analog to digital converter using the SPI protocol from a fischertechnik LDR, light dependent resistor, an ordinary LDR, an NTC, negative temperature coefficient resistor, and a bit more stuff. Last time I found out that the problems with the SPI values were due to this piece of wire. It was still in SPI 3-wire mode from a previous experiment. For that experiment, please see my Raspberry Pi Series 3 videos. And I am now using Octave as well to gather data. So although you won't see anything spectacular happening here, except me laying a finger on here or covering this for changing some values, everything happens on screen. So let's go watch that. And then full screen. First, webcam used for the in-screen video. Then minicom serial terminal, necessary to start the virtual network computing environment, which you see here, but also necessary to see if there's anything going wrong. Then of course the oscilloscope, which is set to RS232 serial connection, which are probed by the probes connected to the serial port that I showed earlier. Then VNC connection, Pi scope, which is an internal oscilloscope, currently showing nothing, but it should show when the program is running MISO, MOSI, clock and some data, as well as TX and RX, which is serial. Well, obviously this is the program that is here, and it is sending all kinds of data through serial line as well as to screen. Then this is once again the view for Raspberry Pi camera, and let me put it a little bit closer to the camera, whereas this has to be, yep, that is better. And not there's much to see, no blinking LEDs, etc. And this camera I have to shift a bit now. And then, very important, the Octave environment, where I, compared to last time, changed a bit. LDR I've made into zeros, but most important, this. In preparation of this experiment, I added this 12 bytes. Have to be 12 separate bytes to catch everything. Question is, how will it be done? Because the problem is, this is converting the bytes into ASCII. Bytes is readable but not intelligible. ASCII is everything you read. SPI, max, etc. All intelligent or intelligible text is ASCII. So character data is converting raw bytes into ASCII characters. And I will show you, of course. That is to say F5, and there you go. And then I first have to start this. So there we go. Here we see everything going on. Alright. Now there's a few things that I want to change. I need to change. First of all, keyboard stuff. I want to end it nicely. So what I want to do is say serial close. I want also to flush the serial. Not quite sure if this is the command, but I will find out soon enough. And okay, let me grab this one, because I already did it here or here. Well, let me take this one. And I'm primarily interested in, no, not this one. If you have multiple codes, then it is interesting which happens when. Let me take this. Is this? Yes, this is holding it. Okay, so I'm copying this one. And oh, serial flush I need to do. Okay, so this one goes here. So now I can interrupt everything with a break. And this is serial. Yeah, this should be it. Alright, now let's continue. So go. And now ending with an X, which works perfectly. Alright, now I have all this. Now what I want is putting data in here. So my intention is to grab ASCII and put it in data and then see how that works out. And in other experiment that didn't work out as I expected. So let's see how it works out here. Right, so with the new version of software running, as well as this running without any value, by the way, here everything running nicely, getting input, and if I press here, then you see that there's data sent on the other way. 1, Here you see, by the way, that data is garbled again because I am receiving on minicom as well as with Octave, as seen here. So I better quit this one. Alright, then quit. And now I need to see the content of data, which is 0. That is not good. I fill everything with zeros here. Oh, yeah, I forget something. I have to put everything from this here. Now it will get anything and everything. So let's do it again. At least that's the idea. No, I shall first have to run the program again. Now I get something that I don't want to see because this is bytes. This is not ASCII. So let me put it in a different way. First, I am going to show data, and then I'm going to show first ASCII and then data, and then see whatever happens. So first exit, run it again, and this is also not what I expect. Although, is it? Let me see. Interrupt by an X. So it says LDR value is 0, which means that this is LDR value or something like that. This is supposed to be value 0. So the 5th character is an E, is 117. Here the 9th value is an E. 2, 4, 6, 8, 1, 2, 3, 4, 5, 6, 7, 8. It's the 9th value. Although, yeah. Oh wait, no, it's really the 9th value. So my conclusion is incorrect. Anyway, or this is a space, of course, and then it is the 6th value, then it is 101, and the 9th value is 101, so that's correct. Alright. Anyway, why is this not working out the way I expect it to be? If I put a quote here, it means I am transposing it, which means vertical becomes horizontal, horizontal becomes vertical. Is that the way it is going to run? And that is not good. Inverted left hand side. So if I do differently, wait, nothing here, and I say okay, now I want data, and I transpose. Is that what I want to see? Then I have to do it like this. So this means no data, and this means data on screen. Well, that is indeed what I like, although data is not really what I expect. I expect this to be strange. Very strange indeed. So this is pushed out on screen, this is pushed out on screen, this is silent. This whole line is silent, this whole line is silent. And yet I get this. But why is this in bytes anyway? That's a strange thing. I fill it with ASCII, so I expect ASCII. Or is this a way to ruin it? Good question. Alright. The weird thing now is that here, as you by now know, I managed to get the bytes into ASCII. So if this conversion works, why do I not get all the 12 bytes, all the 12 characters into this array? Or into this vector actually. Next that I try is to put everything that is in here, which are actually back to bytes, the same thing over again, except that I use not character data, I am using the contents of data with a capital. And I actually should use not data because that's confusing, but anyway, data 2. So if you look right here, you see exactly that happening. So will that be extendable? Yes, but is that logical? Not really, because what I want to see is a complete string of it into. Okay, now let's find data 2. Yeah, and that's only this. It's only what it's entered the last time. And that is absolutely not what I want. I want a complete string. Although, let's see. Yeah, this is only one space and another space, so you won't see it. So if I go on and I exit it, now data 2 I get LD. So if I extend this in the same way, 3, 4. Oh, that is not good. This is good. And this is good. 4. 5. And this is then indeed 5. 6. 7. 8. 9. And I have to go to 12. So these are 4. Oh wait, I'm making a mistake. No, I'm not making a mistake. A character is being done on the whole thing. So that's in itself good. this needs to be 10, 11, and finally 12. So now let's see whatever happens. Okay, exit. Now I want to see data, which is this one. So now I have actually filled an array with the data. So I'm not losing it anymore. This I lost, but this I didn't lose. Now the big question is, why do I need this? Because this is double conversion. Converting it to ASCII. This is somehow an automatic conversion back into bytes, and this is back to ASCII. Why can't it be in another way? Or can it be that I'm doing it the wrong way? Which is also possible. Now the thing is though, what I'm after is recognizing LDR values and LDR2 values. And I'm not there yet. But I have the feeling I'm on my way. Then, okay. That is Octave. This is still going on. For some reason though, if I go to the camera and hold my finger on it, there is absolutely no change in value. None at all. So let me quit this one. There is nothing changed in the wiring, so all should be alright. Go. Still nothing. Okay, let me bring the light into it. Light source much closer. And again, hiding this one. So why is this not working? Looking at this makes no difference, of course. So, and yes, it has 5 seconds delay, so that's no fun at all. 5 seconds. 1, 2, 3, 4. Okay, 4 seconds. So it's no fun using this. Anyway, what next? Alright, so I can do what I like to do, but not with regular expressions, because that seems to only work with strings. So that works like finding a match in a string and then assigning it to a variable or putting it into another vector. What I need is regular indexing, and that is going to be a problem, because when I look here, you see that here, by the way, already, resistor is much longer than NTC value. So indexing, then you have to know exactly after how many positions you are with the correct cell. So I would need to truncate everything or give some other names, and then know where everything is in the index. Plus 5 plus 5 plus 5 is 5, 10 and 15, and that way you can index. So I have to change that, but given the time, I have to postpone that to next time. And then I hope I can put everything into its correspondent vector, like RDR, LDR1, etc. And then I would, so this is not working at all. So this will be use indexing. Does this work anyway? Well, yeah, so far so good. Still the question, why are things the way they are now with double conversion, but so be it. What else? Well, this is nicely running, although still within 200 milliseconds, etc. change. So that is not changed. Yeah, this is still the same. The probes are still working nicely, as you can see on the oscilloscope. The only thing that I don't like is that I don't get any values in here, so I have to look into that as well. And the rest, well, this is not really useful right now. If I can manage to have an LED in there, which would be nice, but the voltages are very low, so an LED wouldn't work. And I think that's a wrap. And that's it for now. So let me position the cam like this, much nicer. So you can see this circuit, which gives no value so far, and the probes. That is the most important part. Oh, including of course the serial interface, because I'm reading everything over serial. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. Always appreciated. You can also follow me via Instagram and Twitter. Please show your support by making a donation via PayPal or Wired. And you can also choose to become a patron and have your name mentioned. More information on donating and my project is on my website, and everything is also listed under this video with links, etc. This is obviously going to be continued. Have a nice day and bye bye.